Hey, Fourth year, and welcome to this lesson on the reactivity series and the reaction of metals. Okay, so what we already know from metals is metallic bonding. So what we're going to do first is we are going to go over the answers to the starter that you just completed, which was question 1 on page 17. Okay, so first question was asking you to draw a diagram and labeling an image of the metallic bonding. You should have something that looks like this. I'm not expecting that many ions, by the way, like those three will be fine, okay? But what you do need to have is you need to have the positive metal ions in a really arranged structure, not all over the place, really regimented in rows and columns, and then dotted around the electrons, okay? Don't have them in any kind of pattern. They are meant to be free-flowing. They're meant to be in a random arrangement. And then if you label it positive metal ions and the sea of freely moving negative electrons or sea of delocalized electrons is what I would say normally, okay? I would always try my very hardest to make sure I had the same number of positive ions and electrons. That's not necessary. That's just because there is the same number of electrons and positive ions, so I like to make sure there is. Don't worry if you haven't, okay? Part B was asking you to describe a metallic bond, okay? So the metallic bond is the electrostatic attraction between the positive metal ions and the sea of delocalized electrons. Remember that word electrostatic attraction means the attraction between oppositely charged particles. So in an ionic bond, it's between the positive metal ions and the negative non-metal ions. In a covalent bond, it's between the positive nuclei and the shared pair of electrons. And in the metallic bond, that is the positive metal ions and the sea of delocalized electrons. Okay. Part C was asking you to explain why metals are really good at conducting electricity, and it's because of that sea of freely moving negative electrons. So what I've said is, so you should be writing something along these lines. In order for a substance to conduct electricity, there must be charged particles free to move. Okay. That's true for anything. That's why ionic substances don't conduct until they're dissolved or molten, because the ions aren't free to move until you dissolve it or you melt it. But in the metallic bonds, the electrons are always free to move no matter what state it's in, solid, liquid. Okay, so the metals are really good conductors of electricity because those delocalized electrons are free to move as they please. Okay, so that is the answers to question 1 on page 17. What we're going to do now is we're going to move on and start looking at some new content. So can you get your notes jotted out? I will tell you what slides are notes and what aren't. The first slide is notes, so I'll go through it and then feel free to pause. Okay. So can you take the title Reactivity Series in your notes? You may want to just put a big title above it saying Unit 3, Topic 1, Metals, or something along those lines. Okay. So the reactivity series. What the reactivity series is basically a list of all metals that is ordered in terms of how reactive they are. So what we've got is the most reactive metals at the very top and the least reactive metals at the bottom, and then it's like a gradient. It gets less reactive the further down you get down this series. Okay. We can do some experiments to work out how reactive is to compare the reactivity. So we can put two different metals in water and be like, that one's more reactive than that one. So that one's going to go further up the list. Okay. The three reactions that we can do are oxygen, acid, and water. Okay. Those are typically the reactions that we do with metals to test how reactive they are and compare how reactive they are. Okay. So can you take a moment to pause the video and write these sentences down in your notes? Feel free to unpause when you're finished and we will move on. Okay. So do not write this. This is just for information and to help you while you're watching the 3 videos that I've posted on Teams. Okay. So on a scrap bit of paper, don't do it in your notes. Do it at the back of your notes, like grab a random bit of paper or something. Can you draw this on the paper? So you're going to put most reactive at the top of the paper, least reactive at the bottom, and then an arrow. Make sure there's a decent, well, it doesn't need to be decent, like do this down the middle, do the arrow down the middle. So you've got room on this side to write down the list of metals, and on this side write most reactive, least reactive. Okay. What you're going to do is you are going to, once I'm finished speaking, pause the video and go and watch those 3 videos that I linked in the PowerPoint or the Teams post. They're the same videos. Just it depends what one you prefer to use. Okay. And what you're going to do is you're going to write down what you think the reactivity series is based on the videos. Okay, so you'll watch the water video first and you will write down the order in which they're more reactive. So the more reactive ones go at the top, least reactive ones go at the bottom. This note that I've given you helps. So things that react with water are the most reactive. Okay, things that react with acid are below the things that react with water, and things that only react with oxygen are below the things that react with acid. So what you're going to end up with is the things that react with acid ordered here, the things that react with water ordered in the middle, and things that only react with oxygen or don't even react at all down the bottom. Okay. Hopefully that makes sense. Feel free to ask on Teams if you don't understand what I've just asked you to do. Hopefully it made sense, like from my brain, it made sense, hopefully. So you're going to watch the videos and write down what you think the reactivity series is. Okay, we'll go over what you should have written down afterwards, and then we'll write an official note in our jotters. Okay, so this is on scrap paper, remember. Okay, go watch the videos, pause this video, and then come back. Okay, so hopefully you have now finished watching the videos and now have your scrap bit of paper with some rough notes about the order of the reactivity of the metals. What we're going to do is we're going to go over what you should have found out. So the first video was about reacting with water. Okay, and what you should have seen is that potassium reacted the most. Sodium reacted in the middle, and lithium reacted the least with the water. So what we can do, remember what I said, that things that react with water are at the top. They are the most reactive. Because water's not that reactive, so in order for something to react with it, it needs to be very reactive itself. Okay, so we're going to put them at the top of our reactivity series. Okay. Video B was about the reaction of metals with water. No, acid. So remember what I said, things that react with acid tend to be underneath. Okay, so this is from video B, metals reacting with acid. The most reactive one was calcium. Okay, it basically bubbled over. Okay, the next reactive was magnesium. It was fairly active. There was lots of bubbling. And then we had zinc, which kind of pretty bubbled pretty nicely. Okay. The next reactive one was iron. When he held it up to the camera, you saw that there was like very tiny bubbles on the surface of the iron. Okay, the Fe. So that's next reactive. And then we saw that the tin and copper didn't react at all with the acid. So we don't know the order of that reactivity yet. We don't know how reactive those are compared to each other. We just know it's below iron because iron reacted with the acid and tin and copper didn't. Okay. Then we get to video C. The only new metal that they talked about was aluminium. If you remember, the magnesium reacted with oxygen. Once it was heated up, it reacted very well with the oxygen. Zinc didn't react with the oxygen at all. Okay. It just melted slightly. However, the aluminium didn't react very fast with the oxygen. However, it did get tarnished, which meant that aluminium oxide was being formed. So we can say it's less reactive than the magnesium because it didn't catch on fire, but it's more reactive than the zinc because some of the aluminium at the surface reacted. So we can put aluminium in there. Okay. So after these 3 videos, that is what you should have got. Okay. Hopefully, if you didn't get that, hopefully that now makes slightly more sense about how we get the order of this. Okay. What we're going to do now is we're going to go back to our notes jotter and we will write down a note. Okay. So using the above reactions, we can create a reactivity series. Okay. So this is our reactivity series. We've got the potassium, the alkali metals up here. We've got the order of that shouldn't be read, by the way. just copied and pasted. I've put tin and copper in the correct order. Tin is more reactive than copper. I've also put silver and gold down here because they don't react with anything. Gold doesn't react at all. Silver will very, very, very slowly react with oxygen in the air. That's why silver jewellery tarnishes. It takes a long, long, long time, but it will tarnish after a while, so you need to polish silver jewellery in the same way that you don't need to polish gold jewellery. This is why, because silver is very slightly more reactive than gold, so silver will very slowly react with the oxygen, gold tends not to, okay? What we can say is these are the elements that react with oxygen, okay? Potassium, these at the top are so reactive that you need to store them in oil so it doesn't react with the oxygen in the air, okay? All the way down to copper, maybe silver. They all react with oxygen. These ones react more than these ones, but they all do react with oxygen. These are the ones that react with acid, down to a bit iron. I've probably done that a wee bit too low. Doesn't really matter. I'll explain why in a second. Okay? And these are the ones that react with oxygen. Water. Okay? Can you take a few moments to write this down in your notes? Draw this kind of schematic that I've done. And then I'll explain why we don't need to memorise this. So if you're thinking there, oh my God, do we have to memorise this? No, absolutely not. I'll explain why in a second. Pause the video, write this down, unpause, and we'll move on. Okay, so as I was just saying, you don't need to memorise the reactivity series. And this is because we have something really similar in our data booklets. So in our data booklets on page 10, there is something called the electrochemical series, which is incredibly similar to the reactivity series, that we can essentially use it as a reactivity series. It's used for, the electrochemical series is used a lot more later in the topic. We'll get to that when we talk about reduction and oxidation of metals. But for now, we can essentially use this as a reactivity series. So let me just very quickly get this up so we can have a look what it looks like. Ignore this, I was trying to merge some MP3, MP4 videos earlier for other lesson. So this is page 10 of our data booklet, something called the electrochemical series. Okay, it is essentially the reactivity series. So you've got gold at the bottom, silver, you've got copper, etc. going up. Only difference is the alkali metals are in a slightly different order. That's not that important, because essentially all we need to do for this part of the topic is be able to predict whether something will react more with water, for instance. So it might give you 4 metals and it will say which one is most reactive with water. If it's most reactive, it's the one that's further up the reactivity series. So if you got given magnesium, iron, lead and copper, which one's more reactive with water? It's going to be magnesium because it's further up the reactivity series. Okay, so this is the reason we don't have to memorise the reactivity series that we have just written. Okay, let me just go back to the PowerPoint quickly. Okay, so as I was just saying, using this, we can predict if one metal is more or less likely to react with something like water or oxygen than another metal. Okay. Can you take a moment to write down these final 2 sentences? And then I'm assuming that you've made it to the break at this point. By the time you've watched this video, watched the other videos, taking notes down, it will be the end of the first lesson. So take your break, let that sit in your brain for a little minute. And then come back for lesson 2 and do the practice questions that I've asked you to do. But before you go, let me just go over something in the questions. Okay, so page 17. So remember, for question 2, it's asking you to write down a word equation for each of the reactions. If you remember from the video, it talked about when you add a metal to water, then hydrogen is produced plus the metal hydroxide. So so for the first one, remember hydrogen is produced plus the metal, which in this case is potassium hydroxide. Remember, if it's reacting with acid, you have the salt formed plus hydrogen. So remember how to name the salt. You've got the metal plus, if it's hydrochloric acid, it'll be a chloride salt plus hydrogen. If it's reacting with oxygen, there's no side products, it's just the metal oxide. Okay, and that's the three reactions. Okay, so metal plus water gives metal hydroxide plus hydrogen. Metal plus acid gives salt plus hydrogen. Metal plus oxygen gives metal oxide. Okay, so yeah, that is us done with this lesson. Take a break and then carry on with the questions, and then join the live later where we'll do some past paper questions based on this stuff. Okay, thank you, Nat 5. Hopefully this makes sense. Remember, we are always here to ask questions. If you didn't understand this, ask on Teams, email your teacher, comment and show my homework. We'll get back to you as soon as we can. Okay, thank you guys. I shall see you all in a bit. Bye.